Happy New Year and cheers for a better, healthier 2023 for everyone. I will start my year by putting together all the pieces that I've set up so far to have a fully qualified domain name for my GitOps process with Atlantis. So far, I have set up a custom Docker image for my Atlantis Docker container. I have written Terraform code to push this Docker image to ECR. And last time, I have set up parameter store records where my sensitive environment variable values are kept. So what's next? If you're new to this channel, welcome. My name is George, and you're on Pablo Spot, a space where I show and tell practical examples and sample implementations in DevOps and cloud technology in general. In today's episode, I will be setting up all the underlying resources in ECS to build a fully qualified domain endpoint for my GitOps process with Atlantis. So let's get into it. Let's start coding. There will be two core group of resources that I need to set up. The first set involves all relevant ECS resources, and then the load balancer resources, which will make my Atlantis application accessible through the internet. So let's start with the first set. One of the principles behind infrastructure code and DevOps involves the concept of dry, which is short for don't repeat yourself. This does not only apply to resource code blocks. In some episodes in the past, I have simplified the creation of multiple resources by just having one resource block and a for each property, and also make my code more readable and maintainable. The dry principle also applies to a bigger scale, and today, I will not be writing code from scratch to set up my ECS resources, but what I will do is use a Terraform module that I have created in the past that encapsulates the creation of all the relevant ECS resources for my use case. So if I switch to my browser, if you have stored all your Terraform modules in Terraform Cloud like I do, you should be able to use Terraform Cloud to fetch details of modules that you wish to use. So if I head to my Terraform Cloud account, and then head to registry, and inside this modules section, this ECS module is what I'm going to use for today. And in order to use this module, I am going to copy these configuration details right here, and then switch back to my code. And then if I open my main.tf file, I'm going to head all the way down to this file and plug that in. I also need to enrich this module block and make sure that the relevant required variables in the module are set, starting with the cluster name, service name, and the task family. The values that I'm going to assign for all these properties are arbitrary. The values that you assign for all of these properties are up to you, but I usually make sure to use meaningful words just so I know what they are used for. So these will be the labels for the cluster, service, and task when rendered in AWS. The next module property that I need to set is the launch type, and this property accepts a map value. Inside this map, I'm going to set type, CPU, and memory properties. I am going to set the type property to Fargate, which means AWS will manage the instance that I need for my application. And then I'm going to set the minimum capacity for my CPU and memory. The next module property is the container definitions. And this property accepts a string. But because this is a container definitions property, it needs to be a representation of the configuration properties for the containers to be run inside ECS. So what I will do is set up a JSON encoded version of a list container definitions. The properties that I need to set inside this map include the name, which will be the name of the container, the image property, which needs to point to the ECR URL from a custom Atlantis Docker image. What this means is that if I scroll all the way to the block where I create my Docker image, I will use the name property inside my Docker registry image resource block. So let me head back to my container definition setup. And set the image property. The next property that I need to set is the container port, which I need to set to point to port 4141, which is the default port for Atlantis. Now, this is where it gets interesting. The next set of properties that I need to add in here include the environment and secrets. If you want to know what the difference between these two, head to this episode right here. Now, to set the environment property, I will use the set of non-sensitive environment variables that I have defined inside my locals.tf. So let's quickly have a look at that local parameter. So if I go ahead and open my locals.tf, the local parameter is called env_variables. And because I will eventually have to convert all this into JSON encoded string, I need to make sure that all the values of each element is a string. So let me convert all these Boolean values right here to a string. And also make the port a string. While I'm here, I will also need to set the appropriate value for my Atlantis URL. I will define a local parameter and call it base domain. And set the value to pavlovspot.ml. And then I will also define another local parameter called Atlantis URL. And then I will set the value for this to Atlantis plus the local parameter base domain. And now I can set my Atlantis URL, making sure that I prefix this with HTTPS. And then I am going to append the Atlantis URL local parameter. And now, let me switch back to my main.tf and set the environment property and assign the value from my local parameter. For the secrets, I need to extract all the ARN properties for the parameter store records that I've set up to store my sensitive data. So if I quickly have a look, I have 3 sets of parameter store records that I need to extract from: the AWS access key ID, the AWS secret access key, and a list of bespoke environment variables. So what I will do is head to my locals.tf, and all the way to the end of this block, I will define a new local parameter which I will call secrets. And inside this local parameter will be my AWS access key ID, and my AWS secret access key. And then what I need to do is assign the appropriate ARN for each of these 2 elements. I also need to add the corresponding ARNs for each of the elements of secret variables right here. If I head back to my main.tf and look at how the parameter store records for these are set, I used a for each property to loop through a list, which means this environment resource is a map with each element as the key to the map. So now if I go back to my locals.tf, what I can then do is set a temporary parameter and then obviously this local parameter is a map, and inside this map I will do a for loop to traverse through each element of the secret variable's local parameter, and because the value is expected to be a map, I will need to set a key value pair as an output of the loop. So I will use the element value as the key, and then instead of using equal sign, I need to use the equal and greater than sign to indicate that this is an element of a map. And for the value, I will extract the appropriate item from the resource map based on the element value. So it will look like this. And now that I have this logic set, I can then call the merge function to combine the map for my AWS credentials with this new set of secrets. Which also means I can now get rid of the temp local parameter. And now that I have a secrets local parameter to use, I will head back to my main.tf and add my secrets property and fetch the value from my secrets local parameter. In order to properly start my Atlantis application in ECS, I need to override the command that is run when the container starts. And so what I will do is add another property called command. And this property accepts a list. And then I will add the command server inside this list. I'm not going to expose this service just yet. Instead, I will head straight to my VS Code terminal and prepare to stand up my infrastructure. So I'll start exporting my TF workspace. And then set my AWS credentials using AWS Vault. And then start running my Terraform commands. Now, let me switch to my browser and head to my AWS Web Console. And then I'm gonna head to ECS. And then select my Atlantis cluster. And then click this task definition right here. And then head to the containers section right here and click on Atlantis. My environment variables here look fine. The environment variables that are not sensitive show their plain text values, and the ones that are sensitive show the ARN values, which is what's expected, and that's good. Now let me switch back to my VS Code. The next thing that I need to do is set up the necessary resources to expose my Atlantis endpoint to the internet. This way, I can start doing my GitOps process for my other infrastructure code. What I will need are load balancer related resources, and I have just the Terraform module for this. So let's head to my Terraform Cloud account to check this out. So back to registry. And inside modules, this is the load balancer Terraform module that I am going to use. So let me open that. And then head to the configuration details and copy this. Head back to my code. And I will add the code that I copied just above the ECS module. And for this module to work properly, I need to add input variables starting with the base domain. I have a local parameter that I've set up for this, so I'm just going to use the same local parameter. I also need to set a property called system name, which I will set to a value generic. And lastly, I will add the endpoints property, which accepts a list. And inside this list, I will add the Atlantis string. The next thing that I need to do is attach the load balancer listener that is created inside this load balancer module into my ECS. And to do this, I will head to my ECS module. And right at the end of the block, I will add a new property called endpoint details. And this property accepts an object that contains two properties: the load balancer listener ARN and the domain URL. For the load balancer listener ARN, I will fetch the load balancer ARN from my load balancer module. And then I'm going to set the domain URL to the Atlantis URL local parameter, which is essentially the main Atlantis endpoint. And now, let me head to my VS Code terminal and start updating my infrastructure. And now that my changes are applied and my infrastructure is updated, let me switch to my browser and then head to my AWS Web Console. Select the Atlantis cluster and then head to tasks and verify that the task is running. So far, everything looks fine. Now let me verify if the endpoint is accessible. So let me open a new tab right here and then access atlantis.pablospot.ml. And that page loads up successfully. I have covered a lot of things so far, so let's have a breather. On the next episode, I will make the necessary changes to integrate my Atlantis endpoint with GitHub and start orchestrating my infrastructure through proper GitOps process with Atlantis. In the meantime, let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.